The last categorical dataset that I gave you is a bit of an unusual dataset, but it's relevant to those that are doing biomedical sciences or anywhere where you have multiple experts giving their opinion on some kind of diagnosis or decision. This can include academics on grading projects and essays. If we put student work into different classifications like 2-1 or first or whatever, and two of us do the same marking, do we agree or disagree? So it can be this test procedure that I'm about to show you, either a test of agreement between multiple experts, or you can use it to test accuracy and ability to reproduce what actually happened. Now in this case, because it's predictions about football matches and we can see what the score actually was, then we know what the truth is. But if you've got experts grading cancer samples, you might not be able to unambiguously decide what the grading should be. So if I open this data, there were 10 matches, and truth tells you what really happened. Lawros tells you what Mark Lawrenson's predictions were. Next one says Elena's predictions, and the next one are Hayden's predictions. So the first thing it says to do is create a cross tabulation of this set of data. So you want to do analyze descriptive statistics cross tabs. So here your rows are going to be what actually happened, so you match, and your columns are going to be, whoops, no, not your match, the truth, sorry, and your columns are going to be the predictions by each of the different people. So you press OK. So what we have is a cross tabulation for each of the individuals. So here's Lawrenson's one. So the truth that there was a big away win, Mark Lawrenson didn't got one away win when there was one of those. So he never predicts a big away win. He's a bit conservative. So away win, he got one when there was one. Draw, he got one when there was one, but he got two when it had turned out to be home wins. Home wins, he got none right, and big home wins, no, he didn't put any in there either. For Elena, big away win, agreement. So what you're looking for them to be successful is that they hit on the diagonal. So when they say it's an away win, it's an away win. When they say it's a big away win, it's a big away win. When they say it's a draw, it's a draw. When they say it's a home win, it's a home win. So she's not so good at that one. When they say it's a big home win, it's a big home win. She didn't pick any big home wins. These are complicated to do by eye, so therefore you want to have a proper statistical test, and the statistical test in this case is called the Kappa test. So the null hypothesis within the chi-squared test is there's no preference between the exposed and the non-exposed, or between the different groups. You're equally likely to be in the cancer and the non-cancer case, the disease state or the non-disease state. It doesn't matter what your level of exposure or being exposed or not exposed has happened to you. Now those, each individual person is completely independent, but in this case things aren't independent, because you've got three people making independent decisions, but all based on the same evidence and based on the same games of football that are being played. So you can't use the chi-squared test, you have to use the Kappa test. So you can go to Analyze, and you go to Descriptive Statistics, and you go to Cross Tabulation, and if you click on Statistics here, you can click on the Kappa test. There are some other tests that do similar sorts of things, like McNamar's test. Depending on which one's used in the field that you're working in, depends on which one you're going to click on. I'm picking Kappa as it's the simplest one, and then you press OK. So this measures your Kappa agreement for each of the different individuals. So the basic assumption is that you're picking, the predictions are completely random. You're just saying it's going to be a big away win, draw, home win, big home win at random, and you're not using any sense of expertise. So that is the null hypothesis. And for Mark Lawrenson, you have to say you can't reject the null hypothesis. So you might as well throw at a dartboard. It's completely random for Mark Lawrenson. He's not such an expert. If you go to Eleanor, again, it's not significant. There's no particular pattern. They're not better at predicting than just random. You can't reject the null hypothesis. But for Hayden, you have got a significance here. It's below 0.05. So Hayden is predicting better than just taking random points within the data and randomly assigning each of the games to away win, big away win, draw, home win, or big home win. So that Hayden is actually proving to be a credible predictor, whereas Eleanor is not as good. I mean, she's got a bit of a probability, so it's not completely 0.5, which is totally random, but Mark Lawrenson is pretty much random.